So let's continue writing our functions. So the next function is the model builder, right? So we are going to create our model in this function. So how would that look like? So we would start with saying def model builder, right? And then we have to pass some parameter to this. So we pass a parameter called HP. Now this HP is our Keras tuner object, right? So you will see how we would use this HP. And the first thing we are going to do is to specify the number of hidden layers, right? So I will say num hidden layers, and then I'll say hp dot int, right? So I'll name this hidden layers. The min value should be equal to 1. The max value should be equal to, let me say, 5, right? So yeah, and yeah, let me go all right, I'll just leave it this way. So we specify a number of hidden layers. So we are saying that so this is a Keras tuner object, and then we are saying create a hidden layer. We create this parameter which is called hidden layers. It should have a minimum value of 1 and a maximum value of 5, and it should be an integer. So all these parameters, min, 1, and the minimum, and then the maximum, and then the values in between are all integers, right? Okay, the next thing we are going to do is define a learning rate. So we'll say HP learning rate, and then this is HP.choice. So the learning rate you can specify, I'll use choice here, so I'll say learning rate, right? And then I'll specify a list of values, right? So I'll say maybe 1 e minus 2, 1 e minus 3, and 1 e minus maybe 4, right? So when I'm building my model, use these list of learning rates to find what the best model is, right? Now for now I only need these two parameters. The next thing I'm going to do is I'm going to define my input layers for my numeric feature keys, right? For my numeric key. So I'm going to say input numeric, right? And then I'll have a list here. So I'm going to say tf.keras.layers.input. Then what is the name of this so what is the name of this input layer? So this transform column name, right? What is the shape? of this layer. It's just some one-dimensional shape. What is the data type? The data type is TF dot float 32, right? And then so for column name in numeric feature keys. So this is just a list comprehension. So we'll have a list of all the numeric inputs, right? And then we use the same format for the categorical. So input categorical, right? And that also is a list comprehension. So we say tf dot keras dot layers dot input, and then our name is transformed name column name. What is the shape here? So the shape here is the vocab, size plus the num out of bracket vocabs, right? And then the D type is obviously TF dot float 32, right? And then this is also a list comprehension. So for column name in, so this is not, so for column name, remember that the vocab feature dict is a dictionary. So for column name and then your vocab size in vocab, yeah, I think this is giving me some error here. Shape TF bit, okay, right. So for column name, so vocab feature dict dot items. All right, so I'm still getting some errors over here. So let me see. Column name, shape, D type for column name. Items. Yeah. All right. So that's it. So this is our input numeric, our input categorical, and then now let's create our so the next thing I'm going to do is I'm going to so these are different how do I say it, layers, right? So the first thing I have to do is I have to concatenate. This is a list of input layers. This is also a list of input layers. If I want all of them to be one layer, like I want all the inputs numeric to be one layer, I have to concatenate them, right? So first I have to concatenate this. So I would say input numeric is equal to tf.layers dot concatenate, right? And then I have input numeric. I'll do the same for input categorical. I have tf.layers dot concatenate input categorical, right? All right. Now this is tf.keras dot layers. So tf.keras, right? Dot layers, right? So let me see. Yeah. All right. Then the next thing I have to do now is then I have to concatenate this input numeric and input categorical, right? So then I would say, so I have to combine them, right? So I'll say input, and then let me say tf dot this, and then input numeric, and then input categorical, right? So now we have this input which combines these two categorical input layers, right? So then we can create a dense deep neural network, right? So then after combining our input numeric and our input categorical, we can then create our input. So let's create our dense neural network. So we have created our input. So let's go ahead, and then I'm going to change this variable to, I'm going to call it deep, right? So the first thing is, so let's create our dense deep network. So for so we specified some input hidden layers here. So I'll say for in range number of hidden layers, right? And then I'm going to say, so what should be my number of nodes, right? So my number of nodes should also be something I want to tune, right? So I'm going to say hp.int. Now, if you've realized, each of the hyperparameters, the objects, the HP, right? If we use it to create, so let's say the number of hidden layers, we have to give it a name, right? So hidden layers, because this is very important. When we get to the training function, we have to call this name so that we can get the best number of hidden layers. And then the choice also has learning rate, right? Which is the name over here. So it's the same thing. If we are specifying the number of nodes in our in the inputs, we have to give each node for every layer, right? The number of nodes in every layer should have a unique name, right? So I'm just going to say unit plus string of I, right? So that if I have unit 1, then I know that is the number of nodes in the first hidden layer is equal to that. If I have unit 2, that corresponds to the number of nodes in the second hidden layer, right? So depending on the number of hidden layers we have here, we will have some corresponding number of nodes, right? So the minimum value I'm gonna say should be maybe 8, right? And then the maximum value, I'm gonna say maybe 256. And then we want steps of maybe let me see, maybe 64, something like that. Yeah. And then after that, I'm going to say deep tf dot keras dot layers dot dense number of nodes deep, right? So yeah, for those who have used keras, you understand what this means, right? So yeah, so this would be how my number of hidden layers would be like. So then after that, I can just specify an output, right? So my output would be tf dot keras dot layers dot dense 1 activation is sigmoid, right? And then here the input is D, right? So here also let me see, we can define our activation also here. I'm just gonna name it relu. So you could see that you can also specify the activation function as a hyperparameter somewhere here. You can also specify the kernel initializer as a hyperparameter. So try and do that as a homework. And yeah, so many things that you can specify as hyperparameters. So yeah, so basically this is our small network. The next thing I'm going to specify is called input layers, right? So input, that'll be input numeric plus input categorical. So then we have a list of all our input layers, right? And then we create our model. So we have tf.keras dot model and then input layers, and then our output is output, right? And then we define some training parameters, right? So this is where we have to use our learning rate, right? We haven't used our learning rate yet, so we'll have to use our learning rate here. So we'll say model dot compile, our loss is binary cross entropy, our optimizer is tf.keras dot optimizers dot adam, and then we'll say our learning rate should be equal to that HP learning rate that we specify. And then we say some metrics. This should be binary accuracy, right? And then model dot summary. So if we are working in a notebook, we would see the actual summary of our model. And then I'm not sure if it will also show in the TFX visualization, but yeah. So this is our model. Yeah, probably there will be some errors. I don't know. So we would run it, and then if there are some errors, we'll fix it. The next function we have to specify, which our last function, is our tuner function, right? So we have def tuner, right? And then it takes as input some function arguments, which is of type function arguments, and then it returns a tuner function result that we specified how it should look like in the beginning, right? So we specified how our tuner function result should look like, right? So what goes in this tuner function? So this tuner function, we have to specify the tuner strategy, right? You know there are so many tuner strategies, whether Bayesian optimization or hyperband, or yeah, so many tuner strategies for Keras tuner. So in this case, we are going to use the hyperband strategy, and I will leave a link in the description for all the types of strategies that are available, and you can also read about hyperband and all the other types of strategies that there are. So so we have kt dot hyperband. So the hyperband strategy takes what? The model builder, right? And then our objective, that's validation, binary accuracy. So what is our maximum number of epochs? So I'll say 20. What is our factor? So you can also check what all these parameters mean in the documentation. I'll leave that also. And then we specify the directory, so where we are going to be working. So that will be function argument dot working directory, and then project name, so the project name should be equal to kt hyperband, right? So yeah, and then now we have to specify, we have to load our transformation graph. So load transform output. So we have tf transform output. So tft dot tf transform output, and function argument dot transform graph path, right? And then we now have our train set, right? So train set, that's our input function, and then we have function argument dot train files. We pass this tf transform output to this, and then we also specify I think this was our number of epochs, so we will say 10. So this means that create 10 batches of data set. So every time when the model is training, it would have 10 batches of data. So it says we don't, okay, so this is supposed to be input function like that, and then val set, so input function, so function arguments dot eval files tf transform output also 10, right? So if you know the concept behind creating data batches, so it's so that when you are training, let's say you're training, whenever you're training, let's say you're training on CPU or GPU, after your CPU gives your model some data, right? You don't always want your CPU to, or your model to, just be waiting for data when it needs it. So there should always be data available to your model, right? So that's what this input function does. It will always make sure that there are 10 batches of data available to your model, so that whenever you need the data, it will just feed the data to your model, right? And then we will return some. So this is what we will return. So what we return is a name tuple, right? So this is what we are going to return. It's a tuner function result, right? And this is how we specified how the tuner function result should be, right? So you're returning a tuner function result, and it takes, so that it's a tuner, right? So that is the base tuner over here. So this is the first argument that we have specified, and then we specified some other arguments also, right? So something like the callbacks, right? The callbacks. So we have stop early, which we specified up here, right? And then we have also X, which is our train set, we have specified here. We have validation data, which is our val set, which we have also specified. And then we have steps per epoch, that we have also function arguments dot train steps, right? And then we have also validation steps, right? That's function argument dot eval steps, right? So yeah, this is all we need for our tuner function. So the next thing we have to do is to pass this tuner function to our AI platform, our GCP cluster, and hopefully it will work. If it doesn't work, we would try and fix that error. So let's go and then create our pipeline. So I'm in my command line now. I'm using my Ubuntu WSL. So I'm just gonna do create. I'm gonna do TFX pipeline create. Click enter. So it has finished creating the pipeline. So moment of truth, let's go back. Let's go into our dashboard and see if this pipeline really works. As you can see, you have the tuner component over here. So let's create a run for this pipeline and click start. And let's wait a while and see what happens. So we have a first error. It says model not found. It says no model named SYMPY. I think this library is some symbolic Python library and probably needs it to run some stuff. So what we have to do is we have to add this library to our custom image that we created. So I've added that library to my requirements.txt, and then I will build this Docker file again, and using cloud build, right? So let's go ahead and then I'll gcloud build submit config. So I'll just build and push this Docker file. So our build timed out whilst we were building it. So I'm just going to add a timeout parameter and maybe 1000. Yeah. So this happens, probably the Google servers are overloaded, or yeah. So I'm just add a timeout parameter and just wait. So the push finally happened, but it was very slow. So if it's very slow for you, just go and maybe have a cup of tea and then just wait for it to finish. So I'm going to go ahead and then run the pipeline again. So let's create the pipeline again. So the pipeline was created successfully. So let's see if we would have more errors. If there are any errors related to library imports, I'll change the requirements.txt file. So let's go ahead and then run our pipeline now. So if you haven't watched my videos on creating these pipelines on your local computer before pushing it to the cloud, you should do so, because creating pipelines on your local computer saves you a lot of time, because you can fix all your errors before you even push it to the cloud, right? So let's go ahead and then create a run for these pipelines and start that. So yeah, let me go get a cup of tea and I'll come back if there are any errors. And we have another error. This time it's not related to the Docker image, but related to a keyword. So let's go into our VS Code and fix that error. So the error is here where we specify steps is supposed to be step. So let me do that, and then let me run the pipeline again. So run this pipeline again. So our pipeline has been created. So you know the drill. We will create a run of this pipeline. So create run. Let's start again. Yeah, so there were more errors in my code. So if I go back, so activation was not spelled correctly, and yeah, so that was one error. And let's see what happens. So activation here and activation there wasn't spelled correctly. I'm just gonna go ahead and then run this, and if there are any errors, I'll fix it and then let you know. So there was another error that I needed to fix. So our input layers should actually go here. So because we want a list, so the input layer should actually be here, just after declaring input categorical and input numeric before we do the concatenation. So I'm going to run this again. So finally, we didn't get any errors, and yeah, you can see the model is running now with our tuning parameters. So this is trial number 1, hidden layers 1, learning rate, the unit. So because we have only one hidden layer, we have this unit, the epochs, and it's training, and it would continue. You see this is trial number 3. This is the number of hidden layers that you have. So yeah, and here because we are doing range, so it's going to give you only 3 hidden layers. And it would continue, keep running till yeah, it finds what the best hyperparameters it needs to use. So I'll just let this run, and when it's done, we would continue and just see how this whole thing can be used. So as you can see, the tuner, it's finished running, and yeah, we can check the ML metadata. So we can see that this is the output part. So the output part is in our metadata folder in our GCP bucket. So we can actually go to our GCP bucket and then take a look at our best hyperparameters. So this is my GCP bucket. So just go to your metadata, you find the tuner folder. If you find that the tuner folder has been created, go to best hyperparameters, and it depends. So the latest for me it's 55, but you can check your output artifact to know the number that has been assigned, and then you can just click the URL over here. So when you click the URL over here, it will download a text file, and you can open it with WordPad. So if I open my text file with WordPad, I can see some numbers over here, and what is important is here you can see we have hidden layers 4, learning rate is 0.01, and unit 0 is 200, unit 1 is 8, unit 2 is 8. Yeah, so these are my best hyperparameters for my model, right? So yeah, so basically that is how you can tune your model using hyperparameters and Keras Tuner. And as I said, there are so many other tuning strategies, so you can take a look at Keras Tuner and then its tuning strategies in the documentation. One other thing is, so you can see that when we were doing our statistics, when we were looking at the statistics of our data, we found out that the data set is highly imbalanced, right? Which means you have a lot of people, when you look at the class labels, you have a lot of people who earn who earn less than $50,000, right? So this is something we can consider when we are training the model. We could have added class weights in our trainer, in our tuner, and then found the best buy. It's not really a big deal. We can do that when we get to the trainer function. So when we get to TFX trainer, we would add a class weight so that the model can train better on the unbalanced data set. And also I will show you how you can make use of the hyperparameters without running this tuner function again. So we just make use of this best hyperparameters directly without the need to run this tuner function again when we run our trainer component. So that's all for this video, and I hope to see you in the next video. If you have any comments or concerns, leave a comment and I would respond to it. So see you in the next video.